Start recording, and we'll pull up the first question and see what we got. This is 4.1 9/3. 9/3, and I don't know if this is from this class or the night class, but it is a good test question because I like the way it looks. Now, I don't know what they're going to ask. They could screw it up, but I like anything that has, so I'm going to blow this up a little bit. Okay, there it is. Now, you don't have to draw it, but just sketch it out. And they're probably going to ask you if there's a linear relationship or whatever. So, of course, they do not have a linear relationship because it looks like a curve, doesn't it? So you could honestly say that it's not linear. Is that all they're going to ask? Okay, that's basically it. Let me see if I can take this. Okay, there is the actual graph. Just draw the points. And what they're asking is it linear? Linear means a straight what? Line. So as you can tell, there is not a straight line. It's asking for what kind of relationship? A relationship is how are the dots related to each other? Well, if you take a line and you, even if it's a best fit line, the best fit line is going to look something like that. And that is not a straight what? Line. It's more of a logarithmic or an exponential, which would be an inverse logarithmic or whatever. I can't remember right now. But anyway, it's not linear. Linear would be like that. That's a linear. So, good test question, short and sweet. I think that's what they're looking for. I'm looking to see if they have parts A through Z. Yeah, similar question. So if you hit similar question, this one, linear or nonlinear? Nonlinear. Okay. So that's that question. The next one is 4.113/5. 4.113/5, yes, it is a test question. This is a good test question because it does everything pretty much in 4.1 that I need to do except for calculating the slope. So look at the first one, look at the second one, and look at the third one. And I don't know if it's matching or, okay, they're giving you a, let me draw it because you can't see. So A, they're saying A, the correlation coefficient is negative 0.97. B, they're saying that the correlation coefficient is equal to negative 0.05. I'm rounding. And C, the correlation coefficient is equal to -1. And what they're saying basically is scattergram A, which one is it? Now this is basically testing the strengths, whether you know what the strength of a correlation is. The strength of a correlation depends on what? The number and the steepness, yes. So, which one has the strongest coefficient? C, -1. -1 is because the strongest is a +1 or a what? A -1. So which one would you think has a strong? I would say probably 3. I would say this is the strongest. Why is it the strongest? Because they're pretty much all what? In line. Anytime something is in line, it's going to be your strongest. So that would be 3. I don't know how they want you to do it, but you can do it on your homework. I'm not going to try to figure that out. Okay? This is the weakest. Which set of dots portray the weakest? Yes, because they're what? They're spread out. Okay? And that would be 2. Okay, now I'm no rocket scientist, but if this is 3 and this is 2, then what do you think this one is?
1.
Now, y'all are so smart. And that should be your answer. That's a good test question. That's the kind of questions I will ask you out of 4.1. The only other thing I would ask you out of 4.1 is calculator, you know, finding the R factor with your calculator. I'm not going to ask you to do it by hand. And then maybe finding the slope. There may be a homework question or a test question that asks you to find the slope, which all of you should be able to do. If you can do it on your calculator, that's fine also. But that's the kind of questions I will ask you on the test from 4.1. Capiche? Okay, the last one, 4.2, 7/4. 7/4. This probably comes from the PM class because I haven't covered it yet, but good question. Good test question. First thing I'm going to do is put it in an Excel spreadsheet. I don't care what they're asking. Okay? So here we go. Open in Excel. And the reason I'm pulling it up in Excel is because it does a better job than your calculator. And it's easier for me to get everything on the board. So,
does it allow us to access Excel during our test?
It should. I'll check it and see. Huh?
I tried, and I don't know if I'm like, you have to have it downloaded on your Chromebook Excel.
Well, y'all do have an app on your Chromebook that's like Excel. You might have to copy and paste. You can copy, you can go up here. If you don't have Excel, you can go right here and you can copy in clipboard. And then track. What do y'all have on Chromebook? Do y'all know?
Google Sheets.
What?
Google Sheets.
Google Sheets. Put it in there. So copy and paste and put it in Google Sheets, and then the Google Sheets probably works just like Excel. You just need to play with it. All right, where was I before I was interrupted? No, I'm just kidding. All right, there we go. And enable editing. I'll blow it up a little bit for you. Now, all of this can be done in your calculator. So I'm just going to highlight those 2 columns. Go to Insert, do a scatter plot. There's a scatter plot. Somebody tell me what kind of correlation we got. Okay, I heard one yawn positive, one mumble positive, and then one person say positive. Okay, thank you. All right, so I'll click on there, turn them all on, right click, and add what? Trend line, Hubert. Thank you, class.
Add trend line.
Thank you. You need to be on the radio. Sound like a radio broadcaster. Add trend line. You know what? If you got a voice that can do that, you know you can make all kinds of money.
How much money we talking?
Ask the guy that's doing the Mitsubishi commercials. Y'all seen that guy that does he does the voice for, what's that? I'm not a Transformer. I tried to watch Transformers. I tried all 3.
Optimus Prime?
Yeah, he does the voice of Optimus Prime. Yeah. See, if you can do that with your voice, then how long does your voice last? A long time. Better than your back. All right? So, if you can do that, if you got a voice that can do that, you need to think about it because you can make a lot of money. All right, I'll shut up. All right, set, intercept. No, I'm not going to set intercept. Display equation on chart. There's your equation. Now, if you want to blow that up, you can click on it. I don't know if it'll, no. Sometimes you can, well, I'm not going to worry about it. I'll just write it out. And then, I didn't set the R, did I? Oh, crap. Hold on a second. Display equation on chart and display the R factor. Now, what do you got to do? You got to take the square root of the R squared. So go ahead and do that with your calculator. So we've got Y, I'll write up here where you can see it. Y equals 2.9535x minus 3.3488, it looks like. And R squared is equal to 0.9794. So somebody take the square root of that. And what's the square root of 0.9794?
0.9896.
9896. That's about as close you can get to what? 1. So it's a very strong positive correlation. See, I told you, the relationship between slope and correlation is just about the same. Okay? Except slope, you can have different numbers for steepness, like 5 and 6, where the correlation coefficient only goes from -1 to what? Positive 1. Okay? That's a good test question. Make sure you can do that in your calculator or your whatever book. All right, that's 3 questions that we're going to go over today. Now I'm going to go to counting. Oh, did we do multiplicative and addition? Good. So we're going to go to counting now. Now, everybody in here can count, all right? I'm not saying you can't count. But when we talk about counting, we're talking about factorial. Okay? So I'm going to go to my handy dandy. Well, where is my handy dandy? I didn't pull it up. So let me pull it up right quick. Give me a second. And y'all are 120, whichever one. What's this one? The reason I'm pulling up the PowerPoints, I usually don't use the PowerPoints, but sometimes I use them. What section is this? Somebody look in your outline on the counting section. Is it chapter 5? 5 point what?
5.5.
Thank you. Okay. 5. Oh, there it is. Oh, they do all the sections together. Dadgum. I didn't know that. So I got to go all the way to 5.5. If it says you covering 5.4 or something, we're gonna skip it. I'm not covering it. I'm only covering 5.1, 5.2. What does 5.3 say? Okay, that's fine.
Independence and multiplication.
What?
Independence and multiplication.
Yeah, I cover that. And 5.5. So 5.1, 5.2, 5.3, and 5.5. I should be skipping one section. Am I skipping one section?
Yeah.
Okay. Yeah, 5.4 I usually skip. All right, so here we go. Let me hit the slideshow, that primary. Maybe they got a poster mode on this thing.
To get out.
Yep. Miss Sexton and Miss Thompson, can you see the screen? Just making sure. I want to keep y'all in the loop.
Yes.
One of y'all.
Yes, sir.
Okay, good. They were in the kitchen making breakfast. All right, so I'm not going to worry about that. Okay, the multiplication rule. I'm not going to worry too much about that. Y'all know how to multiply. But in a task of a sequence of choices where the P selections are the first choice, Q selections for the second choice, and R selection, you multiply them together. Okay? Hopefully they're going to give us an example here. Okay, a fixed price dinner at restaurant provides the following choices: appetizer, super salad, entree. So you got a 3-course meal. All right. How many different meals can be ordered? Well, you got 2 right here. 1, 2, 3, 4. 1, 2. So you got 2, 4, and 2. Everybody got that? 2 times 4 times 2. Okay. Now, I'm not going to insult your intelligence by going into that any deeper. If you got 2 courses, then 4 courses, then 2 courses, then you got 16 different meals. Okay? That's pretty much just multiplication factor. All right? Probably not a question on the test because I usually stick with the factorials on this section. Note that in your notebook. I usually stick with the factorials. Okay? And there is the factorial. Factorial. Somebody give me the definition of a factorial in layman's terms.
Multiply by itself.
Not multiply by itself.
Well, the factor itself.
Multiply in sequence down to what number? 1. Why not 0? Because if you did 0, the factorial of every number would be what? 0. So you can't include 0. So what is 2 factorial? 2 times 1. What is 3 factorial? 3 times 2 times 1. What is 4 factorial? 4 times 3 times 2 times 1. You multiply by the sequence, natural sequence, down to 1. That's what a factorial is. Okay, everybody should know that. On your calculator, it's under math, probability. So we're going to find that for those people that didn't invent the calculator and wasn't on the calculator drill team in high school. Okay? A permutation. There's only one word that you need to write beside permutation. Does anybody know that word? Starts with an O. Order. Good. Somebody remembered or watched videos or both. Order. Huh? Okay. Or you read. You read very well. But you're on the back row. You're not supposed to be able to see on the back row. Okay? Order. If it asks for order, like officers on a board, okay? Or the number of horses that come in first, second, and third. Or you run a race and who will come in first, second, and third. Those are all orders. Ordinal. Remember ordinal back in statistics? Those that follow an order. If it has a question of order, you're going to use the permutation. Now, I am not going to ask y'all to do the by hand permutation. Does everybody understand that? And not looking out the window? Everybody understand that? I'm not going to ask you, but I do want you to write down the formula in case you need it. They may ask you on a standardized test in the future, what is this formula? And you need to know what the formula is, okay? So they'll probably show it here and just, there it is. Well, NPR is the permutation. What is always your biggest number, N or R? N. N is always your biggest number. So if N is always your biggest number, what is R? Your smaller number. So don't mess it up. There is the formula. For a permutation with order, it is n factorial over n minus r factorial. And what happens is the n minus r factorial will cancel half the n factorial out. And I'll show you that when we do an example here in just a minute. I'll show you. Okay? And probably most of you already know that anyway, because you've had this before. Most of you. So n factorial over n minus r factorial. I want you to highlight that in your notes. Put a circle around it. Put stars around it. I want you to know it. Not for my test, but for tests in the future, especially entry-level exams for colleges or graduate school, okay? That's one of those questions that are on there, especially any of these statistics and probability questions, they will be on a GRE, okay, because they want to see if you know how to do basic statistics before you go into research, okay? It's just... that's self-explanatory. All right, look at this question. And this is a test question. And it's a standardized test question. They always ask about horses and boards. You know, like the board of directors. They always ask those two questions. So, and every once in a while they'll throw in somebody running a race. But most of the time it's the horses or the board. So, betting on a trifecta. Trifecta is when first, second, third. That's what trifecta is. All right. In how many ways can horses in a 10-horse race n is equal to 10. Come in first, second, and what? Third. So what is r? 3. Okay? So how do you punch it in the calculator? Well, I want you to fill out, and what happens, and some of y'all know this, some of you don't. 7 factorial is really 7 times what? Times 6 times what? Times 4 times 3 times 2 times 1. 7 times 6 times 5, 4 times 3, 2 times 1. So, theoretically, what happens to 7 times 6 times 5 times 4 times 3 times 2 times 1? It cancels out, and you're left with just that. And that's what happens with factorial formulas. Y'all writing this down back there? Y'all want me to write this down? Okay. You wrote down the formula like I asked you to. So that way when it's on the test, you'll know which one it is. Because when you put the permutation formula beside the combination formula, they look almost what? Identical. So how are you going to be able to tell them apart? Yeah, don't write them down. You have to reach down and get out a notebook, won't you? Well, write it down. Oh, you don't have to. Okay, you invented it, right?
He invented it.
No, I thought I don't have to reach down. I said I conveniently have it on the desk.
Oh, okay. He's the one that's going to say, can you go back one slide so I can see the formula? No. Okay. So, how do you do that on a calculator? Well, for those of you that didn't invent a calculator, let's go back to our handy-dandy calculator and pull it up. Oh, I'm sorry. I have to do IT's job here. Just give me a second. At some schools, they have the calculators set up to when you double click on them, they already show up like this. Isn't that something? All right, so what do? You hit, what was the number, 10? And then you hit math, circle over to probability, and go ahead and make a note. Number 2, 3, and 4 is factorial type problems. Okay? So we're going to type number 2, NPR, and then R is 3, and that is your answer. Okay, so I'm going to do it one more time for those that, don't name their calculators. All right, so 10, then math, probability, NPR, 3, and enter. Now, of course, if you want to pull that up again, how do you do that? Second, enter, and it pulls it up again so you can change it. Okay, so if I want to change it to 15, 5, say I do one on the test, and I just change it. Some of y'all already knew that because y'all invented the calculator, right? All right. So that's how you do that. And of course, you can do NCR the same way. 10, math, probability, NCR, and 6. Okay, so that's how you use NCR and NPR. Now, factorial, you can go up to what, 73, I think, or I think it's 69, 68 on this calculator. So you can type in 68, math, probability, and then go down to factorial. And somebody can check, I think it's 70, maybe 70, I think is the highest you can go. But that's a BA number. Okay? That's got 96 zeros in it. Question. All right, that's how you use calculator. All right, let's go back to the PowerPoint, because we got to cover the most important questions, and that's the lottery questions. Okay? So this is a combination. There's the formula for combination, so write that down. See how similar they are? So make sure, because I'd hate for you to miss a question on my test or a standardized test question when you have a 50% chance on it. Okay, because there's only two formulas that you're required to know on some of these tests, and that's the two, the combination and the permutation, and they're very similar. The difference is you have to multiply by r factorial on the combination, basically because you don't have order. So naturally, if you can multiply by more on the combination, then the combination is usually going to be bigger. Okay? Or smaller, I can't remember, I get them mixed up. All right, so let's do, this one is usually committee members. Committee members and lottery. Well, I thought you said board members. The difference between a board and a committee. A board actually has officers, unless you're in a Southern Baptist church. And if you're in a Southern Baptist church, you have a committee for what? Everything. And they put the boards on the committee. I'm a Southern Baptist. I grew up Southern Baptist. So I know you have a committee for restoring the bathroom. And there's a chairman, and there's an assistant chairman of the committee. But usually the committees you don't have officers. Okay? That's just put in by whoever forms the committee. Board members have, officers. Okay? So that's the difference. I don't know. What does this say? Okay, this is something different. I've never seen this question. How many different simple random samples of size 4 can be obtained from a population whose size is 20? Now remember, a random sample is when y'all put y'all's names in a hat. That's a random sample. A simple random sample was if I was to take these two people and call this group A and put their names on a piece of paper and say group A. Boom. Put it in a hat. These three people put their names on a piece of paper and call them group B. Everybody with me? So simple random sample has to deal with what? Groups, where a random sample is single. Everybody with me? So I need to make that distinction because some people think it's individual. A random sample is individual. If I didn't cover that in statistics, I'm sorry. All right. So which one's in? 20. So that means R is, so punch it in your calculator. See if you get the same number. Everybody should get the same number. If you can't work your calculator, then we all know what that means. You suck at life. And you should probably quit school. End up in a ditch. Down by the river. You all know where down by the river comes from, don't you? It's y'all's parents' fault. SNL, Nick Foley, inspirational speaker. Y'all don't have any idea what I'm talking about, do you? You know whose fault it is? Your parents. I want you to Google SNL, Nick Foley, motivational speaker. I don't know his name because I didn't like him as a comedian, but I love that character. What was his name? He died. Not John Belushi. It's after that. This was the 80s. Farley? Chris Farley? Was that his name?
He's funny. Big fat one.
Yeah.
Boy.
Yeah. It's funny. It's hilarious when he goes in and talks to these two kids. He's a motivational speaker. He lives in a van down by the river. And he says that like 5 or 6 times. You need to watch it. It's funny. Develop that sense of humor that some of y'all don't have.
Did you not like You said you didn't like him as a comedian, so you didn't like the movie Tommy Boy?
Huh?
Did you like Tommy Boy?
Because you got to watch the Nick Foley. You got to watch it. That's to understand my personality. You got to understand it. I don't think two idiots running around is funny. I don't think that's funny. Just like people getting drunk, can't find their car, and can't find their way home. To me, that's not funny.
He was trying to save the company, though. It had to be a storybook.
Whatever. All right, did y'all get 4,845? Y'all are on fire. Now, I do not cover this. I do not test you on this, but I want you to write it down. Permutations with non-distinct items. Write that down. You don't have to write down, just write down the formula. Okay? And write down permutations with non-distinct items. And write an example with it. And it's going to have an example here on the next slide. I don't cover it. Why do I not cover it? Because you don't use it as much as the permutation and the combination. You don't see it as much on tests. You don't see it as much on standardized tests. Okay, the number of permutations of n objects, of which n1 are one kind, n2 are second kind, and n sub k, it just keeps on going. And you'll see what on the next page. Just put n factorial, n2 factorial, ... nk factorial. Got it? Okay. And there it is. How many different vertical arrangements are there? And they love flags, especially like the flags on the beach. That's what they like, you know, the red and the blue and the whatever. Okay? That's where they... So how many different vertical arrangements are there of 10 flags if 5 are white, 3 are blue, and 2 are red? Oh, this is a racist question. That's red, white, and blue. That's racist. And then which one's biggest number? That's your 10. You put it on top, and then you put 5, 3, and 2. If that was 1 red, then it'd be 5, 3, and 1. Like I say, I don't cover this very often because really, flags, really? I can understand some of the other questions like board members and lottery. I can understand that. But flags, how many different arrangements of flag? That's, you remember your parents, well, y'all don't talk to your parents anyway. But anyway, your parents used to have this question, and you might have heard about this question that they used to ask you in algebra. If Johnny has $5 worth of change in his pocket, and he has 6 quarters, 5 dimes, and blah, 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 how many pennies does he have? Who the hell cares? That's one of those questions that they make up that really nobody really what? Cares. There's no thinking there. I mean, this is one of those questions, all right? Who really cares? How many different kinds of, unless you're in the Navy, you really don't need to know that, okay? And that wasn't swipe, because in the Navy you have to do flags on ships and stuff, okay? Anybody look up Foley? Nick Foley? Anybody look him up? No. Well, I would do it in class, but somebody would bitch. Okay, here we go. Well, we're going to take off from here. We're going to take off from here. We're going to pull up dang old South Carolina lottery. And maybe, if y'all are good enough, we'll pull up Nick Foley. Because y'all are too lazy to pull him up.
I pulled him up.
It's funny. Did you pull up? Did you watch the whole thing?
I pulled up his name.
Oh, you pulled up his name. Well, we'll watch it. Well, somebody's going to bitch no matter what I do. Some people's sense of humor just doesn't develop. It's like a mustard seed.
There's always going to be that one fun person in the party.
There's always one. There's always one that's going to call the cops. There's always one that's going to tell on you. There's always one that's going to ruin it for the rest of the office. Always. Hubert's rule of life. There's always one. What the heck am I pulling up? Lottery. South Carolina lottery. So, let's go to the Powerball and how to play. And I'm going to pull this up, and you are going to write it down. Because this is a test question, and it is a standardized test question. Select 5 different numbers, blah, blah, blah. Write that first paragraph down. I'll blow it up even further. Dang old short bus size. There we go. Come out, do so, come out again. Select 5 different numbers from 1 to 69 on the left area. Select 1 Powerball from 1 to what? 26. And the question will read something like that. Now there's a couple of things you need to realize about the lottery question. You have to what? To win. Play. You have to play. Now some of these questions, and I'm very lenient on some of these questions, but I'm not lenient if the question states it, okay? If the question says, what is your chances to win? Then that means that the question is assuming that you are buying at least what? 1 ticket. So the fraction will be 1 over the probability. Sometimes the question will say you buy 10 tickets, you buy 20 tickets, you buy whatever. Some questions will say you buy 1 ticket. But there's some old questions in the homework and the test that doesn't say buy 1 ticket. It just says what is your chances, what is your probability of winning. Now, if the question doesn't say any of that, then I'm pretty lenient because it should say it. All right? So, but I'm not lenient if it says winning or if it says 1 ticket, 10 tickets, 5 tickets, whatever. So, how do you do this? Well, the first thing you do is I'm assuming you're buying at least what? 1 ticket. So it's going to be 1 over a bunch of combinations. Well, 2 combinations. All right? And what is the first combination? 69, combination of 5. Where does the 5 come from? The spaces. You can call them ping pong balls, you can call them spaces, whatever you want to call them. But there's 5 spaces, just like on a license plate, okay? There's 5 spaces. It says that. Select 5 different numbers. 5 spaces. So that's R. And N is your biggest number, which is 69. So, with that being said, you're going to have 1 over 69, combination 5, times what? 26, combination what? 1, which is going to be 26. Whenever you have a 1 as a, think about it. You only got 1 ball that you pick. How many different combinations can you have? 26, because you can only pull 1 ball. So it's not like rocket science there. Okay? So I would highly suggest that you do that separately on your calculator and write it out, because it's going to be a very, very, very small number. And while you're doing that, I'm going to go to the spreadsheet. I'm going to show you a trick I learned in a war. Let me go to the spreadsheet. And I'm going to put 1 ticket. No, 5 tickets, 10 tickets, 100 tickets, 200 tickets, 1,000 tickets, 10,000 tickets, 50,000 tickets, 100,000 tickets, 250, let's say 200,000 tickets. 500,000 tickets. 750,000 tickets. 1 million tickets. 1,500,000 tickets. 2 million. Okay, everybody with me? Now, let me go down here. Let me insert. I'm doing this for a reason, so just bear with me. All right. So I'm going to go here and I'm going to say, you can do this on the spreadsheet by using Combin, C-O-M-B-I-N. So I'm going to put right here, I'm going to say equals C-O-M, and it'll pull it up right there. There's Combin. And then click 69, comma, 5. Everybody with me? There's that number. I'll blow these up a little bit so all y'all can see. Because I'm going to tell you a story here in just a minute. There we go. And then what's the other? The other is 26, so equals Combin. Can't type. Oh, horse pookie. Equals C-O-M-B-I-N. Parentheses. 26, comma what? 1, which would be 26. And then I'm going to put over here equals 1 equals this number divided by parentheses this number times this number, and I want to lock both of them. So let me go over here and hold on a minute. Let me do it again. Equals this number divided by parentheses this number F4 times this number, F4, parentheses. All right, that should be your answer, but we're going to change it. And we're going to change this to format cells, number, and I'm going to take it to 10 digits, or 12. There we go. And then we're going to copy that down. Now, one of my professors at Clemson, Mr. James, can't think of his first name, Brawley, Joel Brawley, J-O-E-L-B-R-A-W-L-Y, I think, or L-E-Y. He wrote several books about gambling and statistics. And one of the things that he talked about in class was playing the lottery. And he always asked this question on a test: who's smarter, the person that buys 1 ticket or the person that buys 1 million tickets? And the answer is what? The person that buys 1 ticket. Why? Because the person that buys 1 ticket has the same chance, if you turn all of these, hold on a second, if you turn all of these into percentages, the person that buys 1 ticket has the same chance as the person that buys what? 1 million. Okay? Why did I bring this up? Well, when the lottery came to South Carolina back in the day, I can't remember how long it's been, everybody was worried about South Carolina. Why? Because besides Mississippi, we're the dumbest racist state, most racist state in the Union, right? Y'all don't have any idea what I'm talking about, do you? Yeah. SAT scores, thank God for Mississippi, because South Carolina is always what?
49.
We're always last, okay? And back 20, 25 years ago, when the lottery was coming in, the whole nation was worried about South Carolina because everybody was going to go out and what? Spend all their paychecks because we're ignorant. Okay? So you had all these people from New York and all these people from California and all these people from every state in the union coming down here protesting because we got to take up for these South Carolinians because they're not very smart. Okay? And that's why a lot of people didn't want the lottery to come into South Carolina because they didn't want us giving up all our paychecks. Well, the lottery has been here for 20 plus years, and I've yet to see anybody do what before the lottery came. Y'all ever heard of video poker? Now that's the crack cocaine of the gambling industry. Okay? That's the ones that you saw the kids out in the car, 100-degree weather, they're in their diapers in the car, sweating to death, while mom and daddy are in there playing. That was the crack cocaine. That was what was really going on at the time that the lottery was coming in. And South Carolinians said, let's get rid of those poker machines and bring in the lottery. And it worked out really well. But who is smarter? Somebody that buys one ticket or somebody that buys 1 million? Well, of course, by Dr. Brawley's thesis, the person that buys one ticket is a whole lot smarter than the person that buys 1 million because you have the same chances. Now, do you really have much of a difference with 1.5 million tickets and 2 million tickets? No, you don't have much of a chance. But think about this. If you've got $2 million to spend on lottery tickets, what's the question of what? Why are you playing the lottery? Okay, except you're greedy. So anyway, that's how you do the lottery. So make sure you write this down. Make sure you highlight this right here. Well, I can't. There you go. Make sure you highlight that because that's going to be on your test, and it will also be on plenty of standardized tests. Always put it under 1 because there's a lot of questions that don't put that in there. And if you put it under, if the question is ambiguous or very vague, I will give you credit. But the other direction, I don't go. If the question states you buy 1 ticket, winning, or you buy 5, 10, 15, 20 tickets, I'm not going to mark it correct if you don't do it correct. Okay? All right. Question on that one. Okay. We're going to pull up. I got to turn the recorder off because somebody will complain. At least I won't have it on a recording. Well, if I could get to the freaking recording. All right, y'all hang around, Miss Sexton and Miss Thompson. Y'all hang around. Y'all got to watch this too, because I don't know. Miss Thompson, your father might have showed you. Both of y'all's father might have showed y'all this one because y'all's dang old father, dang old characters. Hold on a minute. No, not